Hi everyone, in this video I want to talk about the difference between system testing and unit testing and what each is useful for. It's going to be a very brief look and we're going to use an interesting example. So system testing and unit testing are used in software to test the system or individual parts of the system, and they're particularly useful whenever you're making changes to the system. So in this example I want to use this door. A system test allows me to see that the door works as intended in its actual environment, in its operating parameters, and it allows me to test the door in its entirety. So I can verify that I can pull down the handle, I can pull the door, and I can close the door. And the essence of a door is that it fills the gap in the wall that when the door is closed, I can't pass through, light can't pass through, and if I open the door, I can pass through, but that I can control that. Now, this door, as you can see, has a bit of a problem. It doesn't quite open easily. And so my system test of using the door as it's intended, of opening and closing the door, reveals that there's a problem with the door. But it doesn't tell me necessarily what that problem is or how I might go about resolving it. And this is where unit tests can come in useful. So unit test is designed, unlike the system test, which I just did. I opened and closed the door as it's intended to be done. That's a system test. A unit test is designed to test each component of the door in isolation and in sort of lab conditions. So if I take a door, generally a door is composed of a large panel that fills the gap in the wall, a handle so that I can pull it towards me. The handle also operates the latch, and the latch is really important so that when the door is closed, it doesn't just open. I have to pull down the handle to retract the latch to allow me to open and close the door. And then I've got a set of hinges on this side that allows me then to pivot the door about its axis. And it's really important that the door has clearance at the top and bottom so that it can be opened and closed. So I could write unit tests around each of those individual functions, or each of those individual components of the door, and use those unit tests to verify that each of those works correctly as intended. Now, the value of those unit tests comes when something stops working, because in this case, the door is not working exactly as intended. So I can run all of my unit tests to define what the problem is. So if I have a unit test that, for example, tests that if I pull down on the latch, or if I pull down on the handle, it retracts the latch, then running that test shows me I can pull down the handle, that does retract the latch. That would be one unit test. So when I pull down on the handle, it retracts the latch. And a unit test should be that small and that isolated. It shouldn't test things that are none of its business. So whether retracting the latch allows me to pull the door out of the wall, that's none of that test's business. Whether the door is able to be pivoted on its hinges, that's not that test's business. That test wants to verify the handle only. So pulling down the handle retracts the latch. That's a successful test. I could also then have another test that verifies that when I retract the latch, that I can then pull the door away from the frame, and another test that says that if I do not retract the latch, I can't pull the door away from the frame. These are all individual unit test case scenarios. So in the case of those two tests around the latch, I may conduct the test by pulling down the handle because that retracts the latch. But equally well, because it's a unit test, I don't necessarily need to do that. I could trigger the latch in another way. I could take the handle off and I could put something else into there and turn it and retract the latch. As long as I'm actually retracting the latch, what I'm testing is that by retracting the latch, I can pull the door out of the wall. Similarly with the hinges, I want to make sure that the door can swing at a particular angle, from one particular angle to another particular angle, and that it flows smoothly and that it can take the weight of the door and so on. So I might write unit tests around that kind of functionality. The important unit test in this case is that the door has sufficient clearance from the floor, and that as long as the clearance is there, the door will be able to glide slowly and smoothly from its closed position to its open position. In this case, that's the test that's failing. The clearance is the problem. The door can't move slowly across the gap in the floor, and therefore that's where I need to turn my attention. Now, these are really important when you make a change to software. So the idea of a unit test is that they're written by the developer who wrote the code. They're not written by someone after the fact. They're written at the point where you actually write the code. So the tests in these cases, when I built the door, I would have created all of the tests for all of those individual things, and I would have ran them as I'm going along. And each time I make a change, so for example, when I added the handle, I would have tested the latch if I'd already done the latch. When I added the hinges, I would have also tested the handle and the latch at the same time. The idea of unit tests is that they're small, they don't depend on anything else, and I can keep running them again and again and again. So each time I add something to the door, each time I change something, I can run all of my unit tests and verify that by making that change, I haven't broken anything else, or I haven't caused anything else to be unable to perform the way it should perform. So in the case of the unit tests that I might write around this door, once I fitted the door into place, or I fitted the floor after the door had been fitted, I should be able to run all of my unit tests and see exactly where the failure is to know that something's wrong. And this is really useful in the future too, because it means if I make any modifications, so for example, if I decide to knock out these two panels and put some glass in, I can then run all of my tests again. So for example, if I put glass in here, maybe that makes the door heavier, and maybe the hinges can no longer take the weight of the door, so I need to upgrade the hinges. I'll find that out by running my unit tests. And it's important to run the unit tests in isolation before you put the whole thing back together and put it back in place, because then it's an awful lot of work to take it all back down again and so on. So unit tests give us an early opportunity to find out that something has gone wrong. So by running your unit tests as you're writing the code, you're giving yourself lots of opportunity to spot individual little problems as you go along. And the only way to really get the benefit from them is to write them as you go and to run them as you go, and do that early and do that often. System tests, by contrast, are done much less often. They're done when the whole system can be put together and tested in its entirety. When you're making changes to a piece of software, generally that happens just at the point where you check in your code. So you might check in your code to the main line, and maybe an automated process goes and runs all of the system tests. Or maybe you have to run the system tests yourself, but that generally happens at the end of the process. But up to that point, I might have run hundreds of iterations of all of my unit tests to verify that each individual piece of functionality still works exactly as intended. And unit tests and system tests have got two very important parts to play in the overall software development lifecycle, and they're critically important when you want to operate in a DevOps way. So we'll look in the future video at how you can use system tests and unit tests in your automated pipelines, and how you can use them to get your software from development into production really, really fast. But hopefully for now that explains a little bit about what unit tests and system tests are and what their value are in the software development lifecycle. And I'll see you next time.